On March 11, 1958, a new era in manufacturing production was born. For the first time in the history of manufacturing, a number of large production machines, electronically controlled, were functioning simultaneously as an integrated production line. Virtually unattended, these machines were drilling, boring, milling, and passing unrelated parts from machine to machine. End products were processed from rough castings through 3 complete and different cycles of machining operations, entirely independent of human intervention. Taped instructions guided the precision movements of the machine tools, and the electronic system maintained complete and unerring control of all operations during the 3 separate manufacturing cycles. The story behind this revolutionary electronic control system began in 1955, when a group of Hughes Products engineers, highly trained and experienced in commercial applications of electronics, investigated the possibility of producing a numerically controlled machine tool line, which would offer complete versatility rather than the single product limitation of the so-called Detroit-type machine. As the research progressed, desirable features of a system equally adaptable to limited production runs in small machine shops as well as large-scale operations were carefully charted and investigated. Exhaustive studies were made of standard machine tool performances. Step by step, the requirements for making these tools completely automatic were satisfied, and a highly versatile, electronically automated machine line, an industrial breakthrough, became a reality. To fully understand the operating procedures and built-in simplicity of the system, let us start at the beginning of a production project. From a blueprint, all factors of operation, including speeds, feeds, and coolant controls, are entered on the planning sheet. The planner thus has control of all variables. After the operations and adjustments have been recorded on the planning sheet, it is taken to the tape preparation unit. This unit consists of a simplified keyboard and 2 punching and verification units mounted at the sides. The design of the planning sheet is duplicated in the keyboard layout so that only minimal training is necessary for operating this unit. As the operator types the information from the planning sheet, keyboard sections are illuminated. If the information is typed in proper sequence, the lights go out. If they remain on, the operator is alerted that a mistake has been made. When all information for a machining run has been typed, the keyboard punch bar is depressed and the information is electrically converted from decimal